You have recently heard about how to solve an absolute value equation. Now we're going to take a look at some absolute value inequalities. We're going to start with one that would be a basic kind of inequality that we can solve and graph pretty easily. We're going to start up here. We can solve and graph this. X plus 3 is greater than 7. I'm going to go ahead and pull up my pen. Make sure it's on the thinner type. X plus 3 is greater than 7. In any kind of equation or inequality, we want to get the variable by itself. That is considered solving. So I'm going to subtract 3 from both sides. These will cancel. That means that x is greater than 4. So if I were to set this up as a number line and make this 0, and I wanted to track 1, 2, 3, 4 over here, x is greater than 4. I'm going to put an open circle and show that it goes in this direction. Remember, when the variable is on this side, whatever way the arrow is pointing is the same arrow that we draw. We can also test it by checking to see if 5 works here. So this is 0.5. 5 is greater than 4. That will be true. That means that we should graph in this direction. All right? Makes sense, pretty straightforward. Now here's the more difficult thing. What if we have an absolute value? It is still possible to work through and graph, but if we have an absolute value, that's going to change how we graph it. So we're going to take a look instead at the absolute value of x plus 3 in absolute value is greater than 7. In a lot of ways, it seems pretty similar. All right, I'm going to go ahead and set up in advance our 0, 1, 2, 3, 4, 5, and then negative 1, 2, 3, 4, 5. All right, so I've got x plus 3 is greater than 7, but I've also got the absolute value to worry about. Now think about it if this were just an equal sign. If we had absolute value of x plus 3 is equal to 7, with an equals, let's ignore this for now. With an equals, we can solve and get rid of the absolute value. What is our rule on getting rid of an absolute value? Well, we have to use the opposite. You know, when we have a plus here, we'd have to minus. When we have a multiplication, we have to divide. When we have an absolute value, we need to take its opposite. The opposite of an absolute value is splitting it into a plus or minus. So the absolute value of x plus 3 is equal to 7 could be rewritten as this. X plus 3 is equal to 7, and x plus 3 is equal to negative 7. In absolute value, both of these are true. All right, let's work from there. The first one will look very similar to how we solved our inequality. We're going to do this same thing, and I'm going to get that x is equal to 4. But on this side, x plus 3 minus 3 on this, and it looks like I'm going all the way down to negative 10. That's a little bit further there. And count 1, 2, 3, 4, 5 more. Put it right at negative 10. Okay, now we need to figure out which way this is going to face. And the best way to do that is to plug in points and to check. Now we know that 4 is going to be one of our boundaries. And we know that 10 is going to be one of our boundaries. Now the question is, are they going to point to the outside? Are we going to say that this is true or this is true for our inequality? Or does it point to the inside? That's the question. Now there is a shortcut to this that we will get to hopefully soon. But for now, let's see what we can figure out. I want the absolute value of x plus 3 to be greater than 7. All right, now how do I get x plus 3 to be greater than 7? Well, I'd need for x to be at least 4. Remember what we did before? We went to the right. So if x plus 3 is greater than 7, then x has to be at least 4. Let's check and see if 5 works. Is 5 plus 3 greater than 7? Yes, it is. That is true. Now, what if we make it absolute value? Absolute value of 5 plus 3, is it still greater than 7? Well, looks like absolute value of 5 plus 3 is just absolute value of 8, even though more like an absolute value. 8 is greater than 7. That works. So that means that in this case, I have to go in this direction. Now, you probably already have a prediction about where this is going. If this one's going to the outside, this one probably is too. Let's check and make sure. All right, if I want for a number outside of this one to work, I can plug it in and check. Let's say I'm going to use -11. I'll use the one right outside here. All right, let's see if this works. -11 plus 3 is greater than 7. Keep in mind we have the absolute values. -11 plus 3 is -8. The absolute value of -8 is greater than 7. Well, what is the absolute value of -8? It is just +8. So that still works. We can go in this direction. All right. So it seems like we have a method so far. We have found the two limits and we plugged it in and solved. Now let's get this to a shortcut. With the shortcut, we're going to look at this one more time, but with this symbol flipped. The same equation. We're still going to have the same boundaries, but this symbol has been flipped. You can already probably make a prediction about it. I'm going to go ahead and set up the number line while we're thinking about that. 0, 1, 2, 3, 4, 5, 6, 7, 8. Going on from there. I left a little bit more room on the bottom this time. 4, 1, 2, 3, 4, 5. Because last time I needed a little bit of extra. 6, 7, 8, 9, 10, -11, 12, 13, so on. All right. So we know that if we're going to remove the absolute value, the way we have to do that is by creating a positive or a negative. Well, if we're trying to make +7 into positive or -7, we don't really need to change the positive side of it. What we need to do is add a negative. What happens if we're multiplying by a negative number with an inequality? Well, we'd switch the direction. So if we want to split this into two equations, we could do absolute value of x plus 3 is less than 7, and absolute value of x plus 3. And if we want -7 over here, multiplying by a negative number means that we are going to switch the direction on this. Okay? And there's one more way that we can write that is, I think, a little bit faster and makes more sense. I'm going to write it like this. -7 is on the bottom. X plus 3 is in the middle. +7 is on the top. So see, if I have this value is less than this number 7, I could take the same symbol and just put it over here with a -7. We can show that with a few other numbers and prove it. There are a couple of things that make the shortcut work consistently, and some things we have to keep in mind, but let's go ahead and solve this through for now. I don't have to worry about the absolute value anymore because I've already established that it's a +7 or a -7. X plus 3 is between 7 and -7. So let's solve this one out the rest of the way. Subtract 3 from each side. These ones are not going to, well, I shouldn't have just crossed them out, but anyway, instead of canceling out, it will turn into +4. And this one, -7 minus 3, -10. All that's left in the middle, this one cancels, that's the one that I should have drawn a line through, is just x. -10 is less than x, which is less than 4. And all the space in the middle is what I fill in. That is how we solve absolute value inequalities.